All right, lesson 3B. All right, so still talking about the rates of change in linear and quadratic functions. And so it starts out here talking about increasing, decreasing, and constant. Now, we already talked about this. We actually already did these first couple slides in one of the previous lessons. So I'm just going to run through it. Just remember that if it's going up, if it's rising from left to right on an interval, then it is increasing. If it is falling left to right on an interval, it's decreasing. And if it's remaining the same across an interval, it's going to be constant. Remember, it does say here, and it points it out, it says it is important to note that the intervals refer to the x values where the y values are either increase, decrease, or remain constant. So remember, we always label these by our x values. Also, don't forget, we're always going to use closed intervals, so we're going to need those brackets unless it's an infinity. All right, and we did the same exact example in one of the previous ones. So I'm going to skip over it so you can exit out. All right, and let's go on to example 7 here. It says, given g of x equals negative x squared plus 4x plus 1 shown at the right, find the average rate of change of g from negative 1 to 3. And so we can see over there that when x equals negative 1, so when x is negative 1, its y value is negative 4. And then when x2 is 3, oops, this should be a g, not an f, I apologize, because it says the g function. So g of 3, so we go to 3, go to the graph, which is up at positive 4. And then we just want that average rate of change. So it's going to be our f of 3 minus our f of negative 1, all over 3 minus negative 1. So it gives us 8 over 4, which is 2. Okay, B says find an equation of the secant line containing those 2 points. So we already know that this is going to be negative 1, negative 4. And this one's going to be 3, 4. And so we are just looking for the equation of that secant line. So it doesn't matter which point we're going to pick. We can use either one of them. And I'm going to plug it into just y equals mx plus b to solve for b. Because we already found the average rate of change, which remember we said that average rate of change up here is going to be the slope of that secant line, okay? So average rate of change is the slope, so we already know that m equals 2. And then I'm just going to use the first point there. So I'm going to use negative 1, negative 4. And so using slope-intercept form, I know a y value is negative 4 equals my slope of 2 times the x, which is negative 1 plus b. So I'm going to solve for b. So add the 2. And so we find that negative 2 is equal to b. And so if we were to use the other equation, we would have still found b was equal to negative 2. So we know our equation is y equals 2x minus 2. And then C says to sketch the secant line. So I already did those 2 points, and I just need to connect them with a straight line now. All right, not perfect. If it had been perfect, it would have went exactly through that negative 2 right there, but it's close. So there's our secant line. All right, example 8. Says the average rate of change of h of x over the interval from 0 to 4 is 18. Find the missing value in the table. All right, so they already told me that average rate of change is 18. And so we know it's from 0 to 4, so there's my x1, x2, y1, y2. So I know that average rate of change is equal to y2, which is, I'm going to put a y there, minus y1 over x2 minus x1. So 18 is equal to y minus 2 over 4. And so we can multiply both sides by 4, or you can put the 18 over 1 and cross multiply. Either way, we end up with 72 equals y minus 2. Add the 2, and so 74 equals y. So we know then that H of 4 is equal to 74. That was our missing value. All right, example 9 says, suppose the demand for a product can be expressed as P of X equals 0.2x squared plus 1.15x plus 5.4, where X is given in units of 1,000. A says to find the average rate of change of demand when the number of items demanded increases from 2,000 to 4,000. All right, so we know our X1, we're going from 2 to 4,000. So X1 is 2. And so we can find F of 2. And so I just work that out, typing it in my calculator, and I find F of 2 is 8.5. I know X2 is going to be that 4. Sorry, this should be P because my thing is P of X. Sorry. And so P of 4. So I'm going to type 4 into that, and I find it's 13.2. So I'm just after that average rate of change. So it's going to be 13.2 minus 8.5 over 4 minus 2, which I guess really what I should have done, let me back up. I should have wrote that it's going to be that P of 4 minus the P of 2 over 4 minus 2. And then we know P of 4 is 13.2 minus P of 2, which is 8.5 over the 4 minus 2. So it gives me 4.7 over 2, which is 2.35. B says to find the average rate of change of demand when the number of items demanded increases from 1,000 to 5,000. So we're just doing the same thing. We know our X1 is going to be 1. So P of 1, so we plug 1 into that equation, and we find it is 6.75. X2 is going to be 5. We're going to plug 5 into that equation, and we get 16.15. So our average rate of change is going to be that P of 5 minus P of 1 over 5 minus 1. So 16.15 minus 6.75 over 4, or 5 minus 1, and then we can change it to 4. It doesn't matter. So I subtract them. I get 9.4 divided by 4, which is equal to 2.35. And then example 10. Says the graph below gives Nikola Technologies revenue, RP, for Bluetooth headphones. The x-axis represents the price of the headphones. Label the x-axis price in dollars and label the y-axis revenue in millions of dollars. Label the function y equals R of P. All right, so this is the price in dollars. And y is the revenue in millions of dollars. All right, A says, at what price will the tech company make no money on the headphones? All right, that means they have 0 revenue. So right there and right there. So at what price? And then explain. So one of them is at X equals $0. So why would they make no money if they're selling it for $0? Well, you can't make any money if it's free, right? So no money made. If free, because I'm not charging them anything for it. And then at X equals, is that $110? And it's probably the point that is so expensive then at that point that nobody's going to buy them. So no one, I'll say too expensive, no one will buy. B says 2 employees are discussing the best selling prices for the headphones. One thinks $45 is the best, and the other believes they should sell for more than $50. Use the graph to analyze this discussion. Is either employee on the right path? All right, well, one of them said $45, and so at $45, they're like up here. The other one said 50 or more, so they're looking at here, or more than 50, excuse me. So, but both of those numbers that they're giving us, both of those prices are close to the maximum, right? And so at this maximum, that's where they're going to maximize their revenue. So are they on the right path? I think so. So since both are close to the maximum, they are on the right path. And we don't know what data they had. They might not have been able to see this graph, okay? That might have just been going based on what they believe or something like that. So, but they are on the right path. They haven't got it down exactly, but they're close. All right, C says the company goal is to have a maximum revenue. What would be the best price for each set of headphones, and explain how you know. All right, so I'm going to go back. It says the company goal is to have the maximum revenue. What price would be the best price for each set of headphones? Well, if I want the maximum amount, that's like right here. Which if I trace this down, so it's not exactly straight, but that would be right about there. So that's about, what, $55? So let me go back to that other slide. All right, so $55. Because it maximizes the revenue. Because it's that maximum Y value, and Y is the revenue, so it maximizes the revenue. It is the X value of the maximum. Or no, sorry. It's the price. There we go. That's better. Of the maximum. Okay, so it's that price of the maximum. Remember, this is just for us there, so remember. Also, though, we could look at it, it's also the average between those two zeros. So if we knew that, we'd make no money when we sold it for $0, and we made no money if we sold it for $110, this is exactly halfway between them. It's the average of it as well. We could have used that. All right, D says between P equals 0 and P equals 55, how much does revenue change on average when the price of the headphones increases by $1? All right, so we're looking for P equals 0 and P equals 55. So, we want that average rate of change. So we know that X1 is 0, and we know that P of 0 was 0. And then X2 is going to be that 55. And so P of 55, you're going to have to go back and look at that graph, because if I go back and look at it on here, then it's going to clear it. But if you go to 55 and go up to the top, your Y value is approximately, it looks like it's halfway between 2,000 and 2,200, so I'm just going to call it at 2,100. All right, we're after how much that revenue changes. On average, we're after that average rate of change. So we're looking at the P of 55 minus P of 0 over 55 minus 0. So we're looking for 2100 minus 0 over 55 minus 0. So 2100 over 55, which is approximately $38.182 million. So, explain. So for every $1 increase in price, because it does say the price increases by $1, so you're just going to put this like over 1, okay? I'm going to change color so it doesn't quite blend in quite so much here on us. All right, so for every $1 increase in price, the revenue increases on average by $38.812 million. Oops. All right, and E says, could there be any factors when the company might alter or adjust the price of the headphone set? Well, headphones is not a staple product, so it's not something you have to have. So it could be considered more like a luxury item, or a lot of people get them for gifts, things like that. So yes, there is a time that they could adjust the price. The price could increase. Okay, at holidays. So like at Christmas, birthday, well, birthdays probably not, but like Christmas, the price could increase at the holidays, since headphones are more of a luxury item. When might be a time that it would decrease? Well, it's also technology though, isn't it? And technology ages and it gets outdated. So when the newer stuff comes out, then the older stuff gets cheaper in price. So the price could decrease. As newer technology is introduced or revealed or released. Maybe that'd be better. Released. All right, and that is the end of lesson 3.